In the previous chapter, we saw that how a single phase AC current is generated and used. But the electricity that is used most widely is the three-phase current. Almost all the electrical power used in the country is generated and distributed in the form of three-phase AC supply. The single-phase AC supply used in homes, offices, factories, etc. originate as a part of three-phase system. In three-phase circuits, coils are marked in different color to distinguish them. So, we have red, yellow and blue wires. The starting end of these wires will be 120 degrees apart from each other. The generation of three-phase current is very simple. We can either rotate the coils in a stationary magnetic field, or we can keep the wires stationary and rotate the magnets. Either way, the EMF will be generated in the coils and we'll get the current. The second method is a preferred way of three-phase generation, as we can have better electrical connections if the wires are stationary. So, the coils are placed in slots and called as stator, and the magnets are called as rotors. Now, to generate EMF and hence the current, we should have a relative motion between the magnet and the coil. The magnet starts to rotate in the clockwise direction. As it passes through each coil, the magnetic flux will link with it. But the flux will be changing as the magnets are rotating. This changing flux will induce an EMF in the coil. The three coils are independent of each other. So, we get three EMFs because of these three coils. As they are displaced by 120 degrees, the maximum current will also be 120 degrees apart in the graph. If we observe the graph, the red coil's waveform is a typical AC waveform which starts at 0. The yellow coil starts with some negative value at the starting point, and the blue coil starts with some positive value. So, all the currents are in different phase. This is how the three-phase current is generated. After it is generated, it is distributed using transformers. Now, let us look at some of the terms related to three-phase circuit. The first one is the phase sequence. In three-phase system, the order in which the voltages attain their maximum positive value is called as phase sequence. There are three voltages or EMFs in three-phase system with the same magnitude, but the frequency is displaced by an angle of 120 degree electrically. If the phases of any coil are named as R, Y, B, then the positive phase sequence will be RYB, YBR and BRY. It is also called as clockwise sequence. Similarly, the negative phase sequence will be RBY, BYR and YRB respectively, and known as an anti-clockwise sequence. The next one is the double subscript notation. It is convenient to describe three-phase voltages and currents using a double subscript notation. With this notation, a voltage such as VAB is more meaningful than simply denoting it as VA. The notation VAB represents the voltage of point A with respect to point B. Similarly, for current, we define the current IAB as the current flowing from A to B by the direct path. In every complete circuit, there will be at least two possible paths between the points A and B. So, if we want to specify the path, then we need to use the double script notation. Now, the last thing about three-phase circuits are the advantages over single-phase circuits. The three-phase system has three live conductors which supply 440 volts to the large consumers, while the single-phase system has only one live conductor which is used for domestic purposes. Now, let us see the main advantages of three-phase system over single-phase system. The first one being the higher rating. The rating or the output of a three-phase machine is nearly 1.5 times that of a single-phase machine of the same size. Next one is the constant power. In single-phase circuits, the power delivered is pulsating. Though the voltage and current are in phase, the power will be 0 2 times in each cycle, whereas in three-phase system, the power delivered is almost constant. Next advantage, the power transmission economics. The three-phase system requires only 75% of conducting material out of the material required by a single-phase system to transmit the same amount of power through same distance at given voltage. So bottom line, it reduces material costs. Finally, a uniform or constant torque is produced in a three-phase system, whereas in a single-phase system, pulsating torque is produced. This is all about terms related to three-phase systems and the advantages over the single-phase. In the next video, we look at how three-phase circuits are connected and used. See you there.